We'll go over the nomenclature of alcohols, ketones, aldehydes, and ethers, starting with alcohols. Alcohols have a functional group, OH, which is an hydroxide attached to a chain of carbon atoms and hydrogens, or even some other groups. So starting with a very simple one. How do we get to name this one? So the first thing is we're going to count the chain that has got carbon atoms, starting with the carbon that is direct attached to the hydroxide. So this is position number 1 of the carbon, number 2 of the carbon, number 3 of the carbon. Well, we don't have a carbon here if we think of that, because we have got an attachment of hydroxide, so the carbon was removed. And so we have got a chain of 3 carbon atoms is called a propane if it is an alkane. But here I'm going to remove the E at the end. So we remove this E. At where it was, I'm going to put a dash. State the position of the hydroxide, that's position number 1. Put another dash. So this is an alcohol, so it ends in O, OL. So that is going to be the name. We can just say propanol. That is still okay. But the propanol, the OH can be also on another position. That's why we need always to state the position. It can also be like this, where I've got the OH here. And still the longest chain is 1, 2, 3. Those are the 3 carbons. And position number 2, that's where we've got the OH. So this will be propan, and then position number 2, and then O. So that is going to be the name. Now there's something really important that you need to pay attention to when you've got more than one OH. So say we have got OH here, then we have got CH2, CH2, and then we have got another OH. How many carbon atoms? Of course, I can also write this like this. It's the same. So when I have 2 carbon atoms, 1 and 2, or 1 and 2. So a chain of 2 carbon atoms, that is called an ethane. So this is going to be ethane. Now when we've got more than 2 hydroxides, we don't drop the E at the end. So this will just be ethane, and then state the positions of the alcohols. One is at position number 1, the other one is at position number 2, and then put di because there are 2 alcohols, diol. So that is how we get to name that one then. Okay. How about this one? How do we get to name this chain? So the first thing is we are going to count the longest chain, and we are going to give priority to the OH, but we need to make sure that the OH receives a lower number. At the same time, we have got a double bond, and we also have a chlorine. Now an alkene has got higher priority than an halogen, so we need to make sure that an alkene receives also a lower number. So naming will start from here. Position number 1, position number 2, 3, 4. There's no carbon here, there's no carbon there. That's the attachment of those groups, you can see. And so therefore, to name this one, we first name the groups which we have. The first group here is the chlorine. So at position number 4, we've got a chlorine, and we name it as chloro when it is appearing as a group. And then this is a butane, so I'll just say but. Okay. And then now at position number 1, I've got a double bond, as we can see. So this is going to be but 1 N. I'll put N like that. So I would have dropped this E when if we had only one OH, but we've got 2 OHs, so I'll maintain it like that. I could have also said 4 chloro, 1 butene. So it is fine like this, okay. And then at the same position, position number 1, we also have an OH, as we can see. So I'm going to put the OH At position number 1 I've got an OH, but it's not only at position number 1. We also have at position number 4 an OH. So and then I'll put di-O. So that is going to be the name for this one, 4-chlorobute 1N1,4 di-O. Let's consider another one. Okay, so here is a compound, and how do we get to name it? Okay, like that. How do we get to name it? Now the first thing is we're going to count and see how many carbons are in the elongation. But from which direction are we going to start counting? We've got an OH here and an OH here. They all have got higher priority. So we are going to consider now the following groups, the groups which follow. An alkene has got higher priority than an alkene and also than a methyl. So we're going to make sure that we give a lower number to an alkene. So let's position number 1, number 2, number 3, number 4 here, number 5 here, number 6, number 7. So I've got 7 carbons in the longest chain. So the first thing is we're going to name the methyl before we can name anything else. Position number 6, we've got a methyl. And this is a chain having a double bond and a triple bond, and it has got 7 carbons. So a chain of 7 carbons is called heptene. Okay, so I'll just say hept and then put the position first of a double bond before I can put the position of a triple bond. So a triple bond is always considered the parent chain when we've got a triple bond and a double bond together. So hept at position number 2, we have got what? A double bond. Now always give it a lower number, will not get a 3. Even this one will give it a position 4, not a 5. Position number 2, we've got an alkene, so ENE. But this is not the whole chain, so I'm going to remove this E. I'll drop that E and put another dash, and then start the position of what? The alkene, which is the position number 4, and then ion. Okay, like that. And then now we are going to state the position. Okay, the positions of the hydroxides or the alcohol functional groups. So it is a position number 1 and position number 7, and then we put di-O. So that is going to be the name of this compound, 6-methyl hept 2N4 ion 1,7 di-O. So that is going to be the name. So basically this is how we get to name alcohols. We can just consider maybe another example before we even get to look at aldehydes and also ketones. Okay, so let's consider this one. Very simple one. How do we get to name this alcohol? From which direction are we going to start counting? We have got a double bond, we've got an OH. Well, we need to know that an OH has got higher priority than a double bond. So this will be position number 1, number 2, and number 3. So this is a prop. Okay. So I'll say prop, and then I'll state the position of the double bond. It is a position number 2. So prop 2, and then N. But I'll remove the N at the end because that's not a parent name, and then state the position of the hydroxide, position number 1, and then put O. So that is going to be the name, prop 2N1O. And what of this one? How do we get to name it? Well, we're going to name the longest chain, and it should be very near to the OH. So it's position number 1, number 2, number 3, number 4, number 5, number 6, and number 7. We can't go in this direction because the double bond won't be counted. We always need to count the double bond because that's got higher priority than the methyl here. So this one, we'll first name the methyl at position number 6, 6-methyl. And then this is a chain of 7 carbon, that is hepty. At position number 6, we have got a double bond, so I'll put N. Okay, and then another thing, but I'm going to drop this E because we only have one OH. Unless if there were two, would have kept it. So I'll drop that and then put the position of the the hydroxide, yes, that is position number 2, and then put O at the end. So that is going to be the name for this alcohol then. 6-methyl hept 6N2O. Let's just consider others so that we make sure that we are so clear when it comes to naming alcohols. Okay, so this is the compound. So how do we get to name this compound? So we have got position number 1. We are going to give position number 1. This is the position number 1. I think this one we've already named it. Yeah, I can well remember we've already named this one. So let me write another one because we've already done that one. So here is our compound. How do we get to name it? So we have got two functional groups in this case. We've got an amine, we have got also an hydroxide. Now you need to know that an hydroxide has got higher priority than an amine, so we're going to make sure that we give a lower number to the hydroxide. And so this one at position number 4, we have got an amine. As a group, we name it as amino. So 4-amino. And then the parent chain has got 5 carbons, so that is going to be pentane. I'll remove the E at the end and put it, that's the position of the hydroxide, and then put O at the end. So that is going to be the name for this one. And what if we've got, let's consider this one. We've got an OH here. We've got this one. We've got NH2. We have got OH. Then we have got double bond that side. Okay. How do we get to name this compound which is here? Now, one thing that we need to notice here is we have got a lot of functional groups, and let's get to identify the functional groups which we have here. The first functional group which we have got an amine. Well, this OH will not be considered as an alcohol. Why? Because it is directly connected to this compound. So whenever we see C that bonded to oxygen and then an OH, this OH is not an alcohol. So this together is a carboxylic acid. So this group is together a carboxylic group. And then we have got an amine group. We have got an hydroxyl group. And then we have got a double bond between carbon and oxygen at the end. So this one is an aldehyde. So we have got 4 functional groups in here. So one of them should have higher priority than the others. And we need to know that whenever we've got a carboxylic is the one with the highest priority as compared to all other functional groups. So when counting, we're going to give priority to the carboxylic group. So this will be position number 1, position number 2, number 3, number 4, and then number 5. So to name now the other groups, so this will be the parent chain. The parent chain of this one is the carboxylic group acid. Now we're going to name the other ones in alphabetical order. So I've got amine, A, hydroxide, we call it hydroxy. For an alcohol as a group, it is called hydroxy. An aldehyde as a group, we call it oxo. So I've got A, H, and O. A comes first, so this is going to be 2 amino, and then 3 hydroxy, and then 5 oxo. And then you name the whole chain, it has got 5 carbons, pent. So it will be pentanoic acid because it's an acid. So that is going to be the name for this one. And the last one on alcohols we can look at. How do we get to name this one? Well, we have got an alkane, a cycloalkane, and an alcohol. An alcohol has got more priority, so the whole this thing is an alcohol. So we're just going to name this compound. So the first position is going to be given here. We are going to go in the direction. So priority is given to the OH. That's why I've started naming from there. We're going to go in the direction that gives the other groups lower numbers. So the second one will be here. Third, fourth, fifth, and sixth. So this one has got 6 carbons. So to name it, we first state the positions of the other groups. Position number 2, we've got a methyl. Position number 5, we've got 2 methyls. So this is 2, 5, 5 trimethyl. And then this is a cycloalcohol. So cyclo, it has got 6 carbons. So cyclohexa, we'll just put ON. So it was supposed to be hexane. Remove the E at the end and put O. So there's no need of stating the position, because even if we state the position, we always start counting from where the OH is, so there's no need. So that is going to be the name. 2, 5, 5 trimethyl cyclohexano. Okay. So let's look at how to name aldehydes and also ketones. Now, the first thing is we just need to get a difference between an aldehyde and a ketone. Well, they really contain the same functional group. What differs is just a little. Okay, so we're going to start with an aldehyde. I'll just write their functional groups and then we start naming them. And then a ketone. Now, an aldehyde, the functional group of an aldehyde is more the same like that of a ketone. For an aldehyde, this all contains a carbon double bond. Now, for an aldehyde, this group, which is a carbonyl group, is at the end of the chain. So we are going to have an R group here, and then we're going to have an hydrogen. This is the end of the chain. But for a ketone, we're going to have a group here, C double bond in oxygen. Instead of having an hydrogen, we're going to have another group that side. So this is the only difference between a ketone and an aldehyde. Otherwise, they're all the same. And when we are naming aldehydes, aldehyde end in Al, ketones end in ONE1. That's from the word ketone. We get the last two. Aldehyde, it's Al. So let's start with a very simple ketone. How do we get to name this ketone which is here? So first thing, we need to identify how many carbons are present. 1, 2, 3. So this ketone is going to be named as propa. So it comes from propane, but we're going to remove the E at the end of propane. State the position of the aldehyde, that is position number 2, and then put 1. So this is propan 2, 1. But for this one, there's no need of putting the position. The reason is very simple. If we change the position of the double bond, we put it here. It is no longer a ketone but an aldehyde. Or if we get the position of this one, we put it here. It's still no longer a ketone but an aldehyde. That is why for this one, we'll not put even the position. We'll just say propanone. So that is going to be the name of this ketone. Let's look at this one. How do we get to name this one? So first we're going to give numbering to the longest chain, and priority is given to the ketone than to the chlorine. So make sure that the ketone receives a lower number. So this will be 1, 2, 3, 4, 5, and 6, 7. If we started naming from this direction, this one would have received a bigger number, and we don't want that. So first name the group. At position number 5 we've got a chlorine, so 5 chloro, and then we name now the whole chain, that is hept. Heptane. Now we're going to drop this E at the end. We just take the position of this OH, I mean the COO, the C double bonded to O. So it is at position number 3, and then put 1 at the end. So that is 5 chloro heptane 3 1. And what of if we've got? Okay, now let's name this compound here. So first thing, let's identify the functional groups which are here. We have got this functional group and which functional group. You can pause out and just try to see if you can name those functional groups. So this functional group, it is at the end of the chain. It is C double bonded to oxygen. It's an aldehyde. This one is also C double bonded to an oxygen, but it is not at the end of the chain. It's a ketone. And priority is given to an aldehyde than a ketone. So naming, we're going to start from here. Say number 1, number 2, number 3, number 4, and number 5. So that means a ketone in this case is going to be considered as a group. The main chain is going to be an aldehyde because this one priority is given to an aldehyde. And for a ketone, a ketone and an aldehyde, whenever they're acting as groups, we give them oxo. At position number 4, we've got an oxo, and then we name the whole chain, that is pent. Okay, it was supposed to be pentane. I'm going to drop this E because this is an aldehyde. This becomes Al. For an aldehyde, there is no need of stating the position because it is always at the end of the chain. So that is 4-oxopentane. And how do we get to name? Let's name this one. Let's name this compound here. Same, we need to identify the functional groups present. This is a ketone, an alcohol, an aldehyde, and halogen. Priority is given to an aldehyde than anything else. So to name this will be position number 1, number 2, number 3, number 4, and number 5. So first name the groups which are here before we can name the whole chain. We have got a chloro, hydroxy, and oxo. So chloro comes first. So 2 chloro, and then we go to the hydroxy which comes second, 3 hydroxy, and then at position number 4 we have got an oxo, that is a ketone. Then name the whole chain, that is what? Pentane, but we remove the E at the end and put Al, so that is going to be the name. Okay, now what if we've got something like this? How do we name this one? We need first to identify the longest chain. The longest chain, of course, is this circle, and we need to name it starting from where the ketone groups are. So that will be position number 1, number 2, number 3, number 4, number 5, number 6. So in this case, whenever we've got something like this will always be a ketone. It can't be an aldehyde because Where do we tell is the end of the chain and where do we tell is the beginning of the chain? So this is going to be at position number 1 we've got a ketone, at position number 4 we've got a ketone, and then this is a cyclohexane. Now in this case, because we've got two ketones, I'm not going to remove this E at the end just like we did on alcohols, and then just put a di 1. So that is going to be the name. Di meaning there are two ketones and then 1. I could have also named it as cyclohexane and then put the positions 1 comma 4 and then we say di 1. So that is also another we could have named it. Okay, so we are still naming ketones and aldehydes. Now let's consider this one. We've got Cl, how do we get to name this compound? Now when we get to look at this compound, how many functional groups are present? We've got an halogen, we've got an aldehyde, we also have an ether. Whenever we see R bonded to oxygen and then another R, this is an ether. So here we've got a methyl there, so that is going to be a methyl ether. Okay, now let's name this one. So we know that this is going to be the longest chain, so first we are going to number it. Priority is given to the kit to the aldehyde, so it will be position number 1, number 2, number 3, number 4. So the rest will be groups. The chloro is a group and also this one is a group. So this is going to be 4 chloro. And then at position 3 we have got if we look at this one, which is what is that? That is a methyl. But it is attached to an oxygen, so we don't call it methyl but methox. And then name the whole chain, that is a butane. But it's not really butane, it is an aldehyde, so it will be butanal. So that is going to be the name then for that one. Okay, so let me see if I can get some other questions. All right, let's consider this one. How do we get to name this compound which is present here? Well, to be able to name it, first we need to identify the functional groups present. We've got a ketone and an aldehyde. Priority is given to an aldehyde, also this will be position number 1, number 2, number 3, number 4, number 5, number 6. So this will be number 7 as the longest chain. This will be a group. So this is going to be 5 methyl, and then at position number 4 we have got oxo, that is a ketone. Then name the whole chain having 7 carbons, that is hept. So it becomes heptana. So that is going to be the name for this one. And that's how we get to name ketones and also aldehydes. So what is remaining to name is ethers here. Okay, so let's get to see how we name ethers. Now as we said, ethers have got R, O, and then R. So we've got an oxygen at the middle, and then we have got a chain of carbon atoms, a chain of carbon atoms. How do we get to name that? Let's consider this one. So to be able to name this one, what we just do is we're going to look at, we have got two groups. We've got a group here and we have got a group here. The shorter one is always considered as a substituent. So we've got 1 carbon, and then 1, 2, I've got 2 carbons. So the name for this one is going to be, we're going to first name this. The substituent includes also the oxygen, so that will be called methoxy. And then this one here is just an alkane with 2 carbons, so that is methoxyethane. What is the name of this one? And how do we name this one? We can see this one has got 2 carbons, one has got 2 carbons. So this is going to be ethoxyethane. As simple as that. So how about this one? How do we name it? Well, when we see this one, priority is given to an hydroxide. An alcohol has higher priority than an ether. So this changes from being an ether to being an alcohol. So this will be position number 1, number 2, and then this one is just 1. So the ether is going to be a group. So we're going to say this is 1-methoxy. We are naming it methoxy because of the methyl which is attached to an oxygen there as a group. And then the whole chain has got 2 carbons, so that is going to be ethane. I'll remove the E at the end, put a dash, and then state the position of the alcohol, position number 1, and then put O. Well, if it was something like this, so still priority is given to the alcohol, so we're going to name it as a longest chain, position number 1, number 2, and then this is going to be considered as a group. And so therefore this is going to be given the name. At position number 1, we still have what? A group there. Okay. Position number 1, we have got a group. And by the way, I put a wrong position here. This thing was at position number 2, not position number 1. It is the alcohol which is at position number 1. So to name this one, this group is at position number 1, so that is going to be 1-methoxy. And then this is an ethane, but I'll drop the E at the end, put a dash, and then put a position of the alcohol. It is position number 1, and then O. So that is going to be the name in this case for that one. So now let's look at just a last one, maybe, or just a few ones before we can even get to finish. And this one, now we're combining everything that we have done. How do we get to name this one? So if we look at it, it's an alkene. At the same time, it's an aldehyde. So position number 1 will be given to the aldehyde because it has got higher priority than alkene. And so to name it, it is an alkene of 6 carbons. So this is going to be hexy. State the position of the double bond, position number 5, and then put ENE. So X5N. But this one I've named is an alkene. But this is not an alkene, it is an aldehyde. I'll drop the E at the end and then put AL. So that is going to be the name. But I'll not put the position of the double bond with oxygen because an aldehyde, the functional group, is always at the end. Always at the end. Okay. And how do we get to name this one? So we'll start naming from here. Position number 1, numbering 2, 3, 4, and 5. So first name the methyl, which is a group. So we have got 2-methyl. And then we'll name now the ocean pent. At position number 2, we have got, at position number 3, we've got a double bond, an alkene, and then N. So 2-methyl pent 3N, but this is also an aldehyde. I'll drop the E at the end and then put AL. So that is going to be the name in this case. Well, let's look now at the last example. and then we'll be able to conclude in this video. So here is our chain, and we've got an O there, we've got a double bond here, we've got an amine here, and then we have got an OH here. First, which one is going to be the main chain? So the main chain, how many carbons are here? There are 5 carbons. What of this other one? 1, 2, 3, 4, 5, 6, 7. It has got 7 carbons. So this is going to be the main chain. So the rest are groups. So I've got this group, got this group, this group. Okay. So we're going to name the groups before we can name the main chain. And we have got an amine, that's the one which comes first in the alphabet than everything else. And what position is it? At position number 4. So 4 amino. And then what else? Position number 5, we've got an hydroxy. And then at position number 7, we also have this compound. What compound is this? It is a pentane, but it's not just pentane, but cyclopentane. But we'll not name it as cyclopentane. It is a group, so it will be cyclopentyl. And then now we name the whole chain having 7 carbons, that is hepty. But remember, there is also a double bond at which position? Position number 2. So hepty 2n. But this is not an alkene, so I'll drop the e at the end. The priority functional group, most priority, is an aldehyde, so I'll put AL at the end. So that is going to be the name for amino 5 hydroxy 7 cyclopentyl hept 2n. Thank you so much for watching the video. Hope it was helpful. Enjoy your day.